Hey everyone, and welcome to another edition of the Molecular Math Science Show. Today we have another classic experiment for you. You've probably seen it before. It's called the tornado in a bottle. I'm hoping to bring some fresh perspective to this experiment, and maybe you'll learn something new today through my explanation. If you've seen it before, basically the experiment is I flip this thing over and I'm going to create a little vortex in there. I like to call it a self-sustaining vortex experiment. The first thing I like to ask kids when I'm doing this experiment is, what would you expect to happen when I flip this thing over on its head? And most people would predict, based on past experience, that the water is going to go from the top bottle into the bottom one. Okay? And that's what we do in science in general. We take all of our past experiences and then we use all that information to make predictions about future experiments. So I've seen water move downhill plenty of times. I've seen it go over a waterfall. In general, it's going to take the path of least resistance. And if it's unobstructed, it's going to go from this bottle into this one when I flip it over, because I can tell you there is a hole in here allowing the flow of water. So that's my prediction. Again, based on all my previous experience, and so that's what we like to call a hypothesis before going into the experiment. My hypothesis is that the water is going to move fairly quickly from this bottle into this bottle. Here we go. Okay, so what I'm seeing here, and let me bring you in for a closer view, is the water is moving from the top bottle into the bottom, but it's going pretty slowly. And considering that there's no obstruction here, the question is, why is it moving so slowly? What we're basically seeing here is it moving one drop at a time. And so there seems to be a bubble coming up from the bottom and then a little bit of water going down into the bottom bottle. But if I create the self-sustaining vortex I was describing before, something very different happens. Give it a little spin, and all of a sudden it's moving much quicker, as you can see here. And we've got that little tornado in a bottle that I was talking about. And so the water is flowing much quicker. I'd say 3 to 4 times as fast as in the beginning when it was just moving sort of drop by drop. And the reason for that, that has to do with several things. The first thing I didn't ask you before I did the experiment was, before I flipped the bottle, is there anything in this bottom bottle here? And the answer would be yes. There's clearly, it's filled with about a liter of water. This is a 2-liter bottle. And the next question is there anything in this top bottle? What do you think? Well, there actually is something in there. Although it may not seem like it, there is air in there, right? And air is a thing. Air is all around us, and we kind of forget about it. So, just because we're sort of swimming in it all day, much like a fish swims in the ocean. But air is a thing. It is matter, and so it takes up space. And that is the reason for the slow movement of water without the vortex. You see, the air is taking up space in the bottom bottle. So the water can't just easily flow from the top to the bottom. It needs to make room in the bottom bottle here. And so that's what these little bubbles are. A little bubble goes up, and then a drop of water goes down. And there's this sort of very slow, kind of tedious exchange of water for air between the two bottles. But when I create that self-sustaining vortex, what we see is there's a more even flow. There's an even exchange of water in the top for air in the bottom, because I've created a column of air going right up through the water in the top bottle. So then air can constantly be flowing from the bottom to the top and water flowing down into the bottom. So this is moving much more like we would expect, more like a waterfall. So that's it for today's experiment. If you get a chance to try this at home, it's really cool. You can find these little connectors, tubes, things online, and then you just get two 2-liter bottles and you can make it yourself. It's a lot of fun. You can show your friends, teach them all about the states of matter and how, in fact, gas does take up space, although we don't normally think of it to do so. In a closed space like this, the air in there is going to take up space, just like water takes up space, just like solid things take up space. And so, a lot more to this experiment than you may have thought. So keep coming back for more experiments from Molecular Matt, and keep that science mind active. Always question what's going on around you. That's what makes us human. That's what makes life so interesting. Keep asking questions. Question everything.